Number 3, this question is about the parametric equations. And in the first part of this question, we are asked to find we are asked to show the derivative of y with respect to x can be written as k cosecant x, cosecant theta. And yeah, so here is the thing. If I'm asked to find the dy over dx, and the x and the y both defined parametrically, so we can use a chain rule, and we can say that, oh, that means dy over d theta is the same as d theta multiplied by d theta over dx. So these are the same. Okay, so these are the same. This one the same as this one, because I can simplify d theta as like so, and then that will be a dy over dx. So all we have to do now is find the derivative of y with respect to theta. So the y with respect to theta is 1 plus cosine 2 theta derivative. That's going to be multiplied by 1 over, because that's d theta over dx. Okay, it's not dx over d theta. So if it is dx over d theta, I'm not going to write 1 over, since it's d theta over dx, so I should be writing this as 1 over, I'm going to be writing the detail over here that turns into as a dx divided by d theta. I meant to write here d theta. I'm going to come to that part in a second, okay? So let me just take it all the way here. Okay, so 1 plus cosine 2 theta. 1 is derivative is 0, we don't write it. Cosine 2 theta, so we need to find the derivative of cosine 2 theta first. That's going to be sine 2 theta. And then that's a composite function, so you need to multiply it by the derivative of 2 theta also. Okay, so the cosine will give us like a negative sign. Cosine will give us a negative sign, and then you should be multiplying by the derivative of theta, the inner part, okay, 2 theta. All right, so that means the next part is just simply going to be 1 divided by dx over d theta. So I need to find the derivative of 3 sine cube theta altogether derivative. Okay, be very careful with these functions. That's a composite function also. 3 sine is cube theta, which you can actually solve with the chain rule. Do not forget to include everything, okay, so in your derivative. So be very careful when you have a composite function when you're finding a derivative of it, okay? So then 2 theta will give us negative 2, and then times that negative sine 2 theta. So just like multiply this all, like this is 2 and then multiply by that. And let's multiply it by, now carefully, I'm going to be keeping 3 here. So for a sine cube theta, so I'm going to be finding for sine cube theta as just simply like x cube. If it is x cubed, that will be 3 times x squared, but it's a sine, so that means sine squared theta. And then you should be multiplying this by the derivative of sine theta. Okay, so don't forget this is a composite function. We're applying the chain rule there. Okay, so I'm going to be writing this as, let me write this as negative 2 instead of sine 2 theta. Let's write 2 sine theta and then the cosine theta. I'm almost done with this. There's a 1 on the top, there will be a 9, and I'm going to have a sine squared theta. And then derivative of sine will be cosine theta, and that's almost done now. We have a couple of things to simplify, and this cosine simplify with the cosine, and then the 1 of the sine will simplify the sine on the top. I'm going to have negative 4. I'm going to have negative 4 divided by 9, and there will be multiplied by 1 over sine theta, which can be written also 4 divided by 9, negative 4 divided by 9 cosecant theta, and I'm done. Okay, they say show dy over dx can be written as k times cosecant theta. So the k is basically -4/9, and then the cosecant theta. Okay, that's a really long question. Okay, so the second part of this question, they say the point P lie on the curve C where theta is equal to pi over 6. Find the equation of the tangent at this point. We need to find the equation of the tangent at this point, and we need to write it as ax plus by plus c equals to 0. Okay, so the equation of the tangent is y minus y1, which is the y coordinate, or you can say the y0, and then the m multiplied by x minus x1. So why I'm writing this, because I need to know what do I need to do to write this equation completely, right? I need to know what's a y1. I need to know what is the gradient. I need to know what's x1. So luckily we can do everything using the point they gave us, with the equation they gave us, and then with the derivative, which is basically the gradient. Okay, so I'm going to be saying m is equals to -4 divided by 9 cosec theta. And they say x is, what was the x? They say x is 3 sine cube theta, okay? So they say x is 3 sine cube theta, and then they say y is 1 plus, if I'm not mistaken, cosine 2 theta. Yeah, cosine 2 theta. Cosine 2 theta. So all I have to do is calculate this gradient at pi over 6, because they want us to find the tangent line at the point where it has a theta, like pi over 6. Okay, so whenever theta is pi over 6, that will give us the gradient of the tangent line at this point as -4 divided by 9 cosecants of pi over 6. So be careful with this, and then you're going to be getting the gradient as -8 divided by 9. You can use the calculator for this part. So that's going to be 3 multiplied by sine cube of pi over 6. So you're going to get the x coordinate as 3 divided by 8, and do the same with the y. Cosine of 2 pi over 6, you can say, because it's 2 thetas, and then the y is going to be 3 divided by 2. Okay, so then the equation is y minus 3 over 2 is equals to the m, -8 divided by 9, x minus 3 divided by 8. So I'm going to be multiplying everything by 18 just to get rid of the fractions. If I multiply everything by 18, let's see what we're gonna have. So that we are going to have, let me write it here, 18y minus 27 is equals -16 multiplied by x minus 3 divided by 8. And and what I can do is I can just expand this one as well, and that's gonna be simply here then 18y minus 27 is equals to -16x plus that will be 6 over here, and then move everything to the left hand side, so it's gonna be 16x plus 18y, and then minus -27 is this going to be as 33. So that's what they want. Okay, so it's done. In the next part of this question, they say show that C has a Cartesian equation, something like so. Let me copy the equations from here. I'm going to be working on these equations. Okay, so here's the thing. So that is giving us, I can say x is equals to 3 sine squared theta. That's multiplied by sine theta. Okay, so remember the Cartesian equation is like x and y, like this is not a big deal. Actually, you need to be doing the rearrangement. That's what I'm trying to do here. Is so I can actually say right now here, the sine square theta multiplied by sine theta is equals to x divided by 3. Okay, so I want to do some kind of rearrangement. So instead of sine square, so let me just try to do something with the y now. I can write this y as y equals to 1 plus, instead of sine 2 thetas, I want to write here 1 minus 2 sine square y. So everything I'm writing here is from P3, that this identities and so on. So that's basically y is equals to 2 minus 2 sine square theta. So let's make the sine square theta the subject. So that's going to be sine square theta. Finally, I can say the sine square theta is 2 minus y divided by 2. That's going to be 1 minus just the 1/2 y. Okay, so instead of sine squared, I can write it here. And there is still a sine theta, so we need to be dealing with. That's going to be the square root of it. Okay, so that's going to be the square root of it. Okay, so if the sine square theta is equals to 1 minus 1 over 1/2 y, that means sine theta is the square root of this. So the simply that I can do, what I can do is I can write here as like this is basically the cube. I can write here a 1 minus 1/2 y to the power of 3 divided by 2 is equals to x divided by 3. Okay, so then I'm going to be squaring both sides. I'm going to have 1 minus 1/2 y cubed equals to x squared divided by 9. How do they want me to write it? They want me to write it's 8 over here. Okay, so what I want to do, and there is a 2 over there. What I want to do now is like the form they want. I'm gonna be taking 1/2 out. That's gonna be a 2 minus y, still all together cubed is equals to x squared divided by 9. So this is gonna give us 1 over 8. 2 minus y cubed is equals to x squared divided by 9. Sort of like we interchanging that as 9 times 2 minus y cubed is equals to 8x squared. So I believe that they want this form, 8x squared, 9 times 2 minus y cubed, y altogether cubed. Okay, so that here it is. That's done. Where q is the constant. Okay, so we need to also find, by the way, the q. So I'm gonna almost forgot that. Forget this. Okay. So I have to, or we have to find also the range for the q, and that's for the x. So for this, I'm going to go all the way up to the equation. Okay, actually not here, just like, okay, so that's where the x is defined, right? Like x is defined between this and this. So you can see this from this equation. So x itself is the 3 sine cube theta. So that's 3 sine cube theta is defined between 3 and the negative 3. As simply this sine cube can be 1, maximum can be negative 1 as minimum, just like simply the sine. Okay, all right, so that's going to be then x is defined between 3 and the negative 3. So that's it. Okay, so for the kind of question like to show it in a Cartesian equation, especially if it is the parametric equation given in trigonometric as a trigonometric functions, you should be knowing a lot of identities. Okay, so as you can see throughout